What if you could move USDC across chains in seconds without worrying about fragmented liquidity or complex transfer mechanisms? With Circle's cross-chain transfer protocol, otherwise known as CCTP, you can do just that. So today I'll walk you through how to integrate CCTP, more specifically CCTP version 2 that has new features such as fast transfer and hooks, as well as programmable wallets to build your very own cross-chain USDC bridge on Telegram. My name is Elton Tay, therefore at Circle, and by the end of this walkthrough, you understand how CCTP enables a secure movement of USDC across chains. You understand how to fork our Replit templates, and you understand how to implement CCTP version 2 in those Replit templates to get started building. Also, for developers watching this video, there's a free $100 worth of credits that you can use for Circle's Web3 services that equates to roughly 1 month of 2,000 active wallets, about 200,000 smart contract API calls, or about $100 worth of sponsored network fees, which is all very helpful. So special thanks to Gen AI for providing me these statistics. So before we actually get started, I have drawn up a naive diagram to showcase how exactly CCTP actually works. So take for instance that Alice needs to send Bob 1 USDC, but Bob wants USDC on Avalanche, but Alice only has USDC on Ethereum. So how does Alice approach this situation? So Alice now has to find a reliable bridge to move her USDC from Ethereum to Avalanche just to pay Bob, right? But there's a problem. Traditionally, many existing bridges uses this concept of lock and mint, which may introduce security risks where USDC is locked in a smart contract that is vulnerable to exploits. Thankfully, there's a technology that enables the secure movement of USDC across chains called CCTP, which is developed by Circle. CCTP is essentially a set of composable smart contracts that is paired along with Circle's attestation service that enables the native minting and burning of USDC. That's why it's so secure. So take, for instance, that Alice has to transfer 1 USDC to Bob, right? She needs to interact with the CCTP smart contract as well as the USDC smart contract on Ethereum, in this case, a source chain, by burning it. So once she has burned the USDC, Circle monitors the event that has been emitted and confirms by testing that it has been burned. And the application that Alice uses just needs to trigger the minting of USDC on the destination chain, in this case, Avalanche to Bob's address. So that's how it flows, is as easy as that. And the differences between version 1 and 2 is that version 1 on EVM chains takes about 13 minutes, now takes about 45 seconds for V2. So the huge difference in terms of time that pairs along with the security that comes along with it. Also, there is hooks, so you can introduce greater programmability and automation in your cross-chain USDC transfer use case. So that is, in a nutshell, how CCTP actually works. And I'll now dive into how you can get started building with CCTP. So to get started building with CCTP easily, you need an account on Replit and an account on Circle Developer Console. So go about creating those accounts you have yet to. And once you have created an account on Replit, go to replit.com/add-build-on-Circle, and it'll bring you to this page filled with wonderful templates for you to get started quickly. The template to focus on today will be the Telegram bot with programmable wallet. So click onto it, click on Remix Template, click on Use Template, and give it a moment and it should spin up a new template on Replit. In here, click on the left side to view the files, and you can actually browse through. You can see the README that has already been opened on the right. And in the README, in step 4, you notice there's 3 variables that you need to have to get started with this repository. So the first one is the API key that you can obtain from the Circle Developer Console. So head to your Circle Developer Console, create an account again if you have not. Under the second item on the left, you can see API and client keys. Create a key by clicking on the blue icon. Then click on API key, click on the standard key, give it a name, and click on create key. Once done, it will show you a API key that's secret. Do not share it around, and copy it. I'm just going to copy mine real quick. Go back to your Replit account, the page that you have already opened. At the far left under All Tools, click onto this icon, scroll down and click on Secrets. So in here, you can see there's 3 values that are missing. So paste onto the Circle API key value and add that secret in. So the second variable is the entity secret. This is needed for you to perform like every unique transactions using our SDK kit. So you need that entity secret. To get that, go back to your Circle Developer Console, scroll down under Dev Control Configurator, click on Entity Secret, click on Learn Registration Process, click on Interactive Quick Start, and scroll down and you can see in here, there's a blue icon that you can click, try it out, and it will generate for you your entity secret. Grab that and go back to the Replit, paste that value in and add that secret. So the last value you need to get is for the Telegram bot, right? And you can obtain that from the bot file there. So in here, you need to /new bot. You need to give it a name, say testing Circle CCTP V2. Okay, then you need to actually end it off with an underscore bot. So I'm just gonna V2 just to make it super unique and bot. Once done, they'll give you an API key that is specifically unique to your bot. Copy it and paste that value. Click Add Secret, and you are almost ready to get started. You can actually view your bot by going to the link here, clicking Start. Right now, it won't show anything because you have yet to start the Telegram here. So in here, you just need to click on the green icon at the top called Run. So now you can see that it's running. You can go back here, you can give it a command again by Start, and it will shoot out the respective commands it has. So in this Replit template, there's a bunch of functions. I will not go through in depth what each of them actually does, but you can view all of them in the 2 files that I'll be focusing today, which is the Telegram service and the Circle service JS file. So you can click on it. You can click on this as well. So in here, you can see a bunch of functions. You can do, you can see the list of networks that I have, hard-coded into this repository for you to view. And in this case, we'll be focusing on Ethereum and Avalanche. For testnet, it will be Ethereum Sepolia, and Avalanche will be AVAX Fuji. So to get started with a CCTP process, is earlier mentioned in the diagram, is you need to have obviously accounts on both sides, right? So we're going to first create a wallet for Alice, and we're going to create a wallet for Bob. So in here, I can perform a function called network to switch the networks to Ethereum Sepolia. And I'm going to now perform the function called create wallet. In here, I've created a wallet. If you want to view like the wallet address as well as wallet ID, you can switch it again. You can click the function address, or you can click the wallet ID. Wallet ID is also very useful because we do have a faucet that you can get like the native tokens as well as USDC testnet tokens. So you can speed up your development like way quicker. So you can also go back to your developer console, click onto wallets to view your already created wallet to make sure that it's actually working. You can see that in here, when you click into it, the wallet ID is 4FE2. Here's a 4FE2. The address is 0x5A. Now we want to fund that wallet, right? So we just need to go to faucet, copy the wallet ID, paste it in, click add funds. I want some native and USDC. So I'm just going to click on it, send tokens, And voila, it's that easy, that quick. Since it takes some time before the funds arrive, let's go about and create Bob's address on AVAX Fuji. So let's go to network, AVAX Fuji. In here, I'm going to again use a function called create wallet. And you'll create a wallet. So what's actually happening behind under the hood for create wallet is we're using Circus SDK kit, right? You can actually view what's actually happening in Circus service. We initialize first the initiate developer controlled wallet client that we have obtained from the SDK kit, right? We passed in the variables from both your unique API key and the entity secret to initialize the SDK client. And once you have the SDK client, it just calls the functions create wallets to create the respective wallets on the respective network. I have dynamically introduced those variables. So this function is all very dynamic. So this is how you create a wallet, is what's actually happening under the hood. Why not just create as well? Why not also fund this AVAX Fuji Bob's address, right? Let's get his wallet ID. I'm going to copy it. Go back to the faucet, right? Just going to give Bob some native as well as USDC because I'm feeling generous. And in here, we give it a moment as well, and Bob should also receive some of those respective tokens. Let's go back and see Alice. Let's go back to the network if Spolia. Let's check out her balance. We can perform this function. You can see she has indeed received 20 USDC. So Alice is now rich and she can send 1 USDC to Bob to Avalanche now. But first we need to create that function. So go back to Replit. Under Telegram service, let's first create a command. Let's create a new command for which is to send, create a CCTP function, basically. So in here, we want to create a new command. I'm going to paste it in here. So what this does is it has a function called \CCTP. It takes in a bunch of parameters before it performs a set function. And the function name is called handle CCTP. So we do need to create a new function. We can do it at the bottom, just before the last parenthesis. I'll just paste it and I'll walk you through exactly how what's actually happening. So in here, what's actually happening is we take the chat ID and the user ID. We check whether there's a wallet first. If not, go about creating those wallet. And in here, we're taking the parameters. So we know that in the diagram, we need to know the destination network. We need to know Bob's address, and we obviously need to know how much you want to transfer. So here we want to split into 3 parameters. First is the destination network. In this case, AVAX Fuji, the destination address, Bob's address, and the amount, which is 1 USDC. All this, I've done it dynamically and split into the various constants here. And I've inputted some messages to show that, hey, it's working. If it's not, there are some errors. Make sure that both sides have an address for this to work. So on the source chain and destination chain, if Sepolia and AVAX Fuji. And this is the most important function, which is the cross-chain transfer that we need to create on the circuit service file. So in here, we need a bunch of parameters to make it work. We need the Alice wallet ID. We need Bob's wallet ID. We need Bob's destination address and the network, the amount, and the chat ID. So let's pass all these variables and go back to circuit service to create that function. We do need to import here before we continue. In circuit service, we need to import VM, which later you see why, is to kind of convert the address to bytes 32. So I will be, importing pet, a function that is pretty new in VM. And in here, I'm just going to install real quick. So you can actually find the shell. And let's stop this so it doesn't auto refresh. Let's npm install VM so that it works later on. And in here, let's scroll down to create our function. So let's go about creating our cross-chain transfer function that takes in all those parameters I've said. So I'm just gonna copy all those parameters, those placeholders, and let's bum. And in here, we need to close the parentheses. So let's get started, right? Start with the try block. Try block, try catch. Yeah, if you just output that. Oh, I love the auto-generated stuff. So in here, it has very kindly provided me a bunch of things. So we do need to initialize the thing. So let's do step by step. So first, we need to do a few things at the very start. We should understand why later on. We initialize by await this dot init. We get a current network. This is an inbuilt helper function that you can explore in my repository just to get the network of where we are. Hence, we do the /network. In here, the USDC amount that you want to transfer in this case is 1. It needs to be converted into big integer for it to be readable. And I have a CCTP file that you can see in config that I have hard-coded all the addresses here for quick reference. So this is me just doing a dynamic reference to the configurations. So the first function that we need to do, right, is approving USDC to a contract. So we need to approve the spending of that 1 USDC before the transfer can happen. So we need to have this function called approve USDC. So step 1, approve USDC. So what's in here? We need to first generate the entity secret ciphertext. You can use the SDK kit that we've already previously initialized, and just generates entity secret ciphertext. This is required whenever you perform a function call with us using SDK kit. So that's why you did it. So the proof function works as such, where it takes in the wallet ID. It uses the function called create contract execution transaction that passes in the parameters of the wallet ID. In this case would be Alice, because Alice is performing the transaction. The unique entity secret ciphertext that has been generated through the API key and entity secret. The contract address that you're interacting with in this case is the USDC contract address on Ethereum Sepolia. The function, which is approve, because you need to approve before you spend it. The ABI parameters, right? In this case, you can just reference the address as well. The amount to be converted to string, and the fee, you can configure it as low, medium, high. In this case, let's put it as low. And I'll just console log to make sure that it has actually done the approval. So once the transaction is confirmed, we need to monitor it. So we can actually use another function to check whether the approval has been completed. And this is how it looks like. So first we initiate a variable called approve transaction status. We use SDK key to kind of get the transaction by passing in the ID of the transaction. We get the state. It will show an enum value, whether it's failed, whether it's confirmed, right? We want to check whether it's confirmed. So when it's confirmed, we just exit the loop and we pass in the, and we just show that it has actually been approved, because it needs to be confirmed on the chain before we proceed on to the next step. So in here, we want to now do the very important function, which is to burn the USDC. So once you have approved it, you can now burn it. Right. So we need a few variables. We say step 2, hey, let's initiate the USDC burn. We need to convert the destination address, Bob's address, into bytes 32. You can just use the VM package pad function to convert that. We do a very naive kind of like conversion for max fee. There's many ways you can go about doing that. In this case, I'm just doing this way. Again, you need the entity secret ciphertext that you can generate using the function. Now we want to create the new like smart contract interaction with, in this case, is the token messenger. So just copy this. So in this, we are interacting with the token messenger, which is a smart contract on Ethereum Sepolia that has a function called deposit for burn. This is where we are burning the USDC. It has a bunch of parameters. And in these parameters, we're taking in the USDC amount, which is the converted big integer to string, the CCTP domain number, which you can find again here. We're sending to AVAX Fuji. So number is 1. The recipient address in bytes 32, which is Bob's address in bytes 32 by using the pad function here. In this case, then we're having this source config. We are interacting with the USDC smart contract on Ethereum Sepolia, and pass in max fee. Here in this, we need to pass in 1,000 if you want to see the fast transfer happening for V2. You can do standard transfer passing a different value, but in this case, I'll pass in 1,000, and I'll put a medium for fee value. And once it's been done, I'll just console log it to make sure that it is actually working. And to get a transaction status, perform it as such one more, as we've done before, to show that it has been burned successfully. So we can again get a transaction by passing the data ID and check whether enum status has been switched to confirmed. And once it has been confirmed, we just output the transaction ID through the message on Telegram. So we're halfway there. We have approved it, we've burned it. Now comes a very interesting part, which is the Circus attestation service, which is shown here. So in here, we need to create the step 3, which is, doing the attestation, right? Let's wait for attestation. Let's do this attestation. And you need 2 things. You need the source domain ID, in this case, Ethereum Sepolia, and the transaction hash from the burn. Let's do the attestation, which is here, to check with our off-chain service whether the burn has successfully been done. We have the attestation received. Once it has been received, we can then do the trigger of minting of the USDC on the destination chain. Right. So for step 4, we want to generate the new ciphertext again whenever we perform a transaction. Right. So you generated entity secret ciphertext, and now we're interacting with a very interesting, a different contract address, which is the message transmitter address on the destination chain. In this case, make sure that your wallet ID now is switched over to, in this case, Bob's wallet ID. Obviously, the entity secret ciphertext, the contract address that you can reference the hard-coded in the CCTP file, and then pass in the API parameters of the message and attestation that is both obtained from attestation variable that you have awaited previously here. Then you can output the response, and like previously approval and burn, you kind of like need to wait for the transaction to be confirmed on the chain. So let's also monitor that event if it has been emitted, whether enum has changed. So in here, we want it to be confirmed again. And once it's been done, we know that the whole end-to-end process from native burning on Ethereum Sepolia and the native minting on AVAX Fuji has indeed happened. Then we'll end it off with a return variable. Here, just want to return the approval transaction, yada, yada. Because what happens is we pass in all these variables that we have already previously asked for here, and we can just output the message accordingly. So the result is here. We know that approved transaction, burn transaction, receive transaction here. So we can see all the output at the end of the burn. So once it's done, fingers crossed, let's try and make this work. Click on run again. Go back to your bot. You can actually see, it will not show in start because here I've not configured, but it should show a new function called CCTP. In this case, we want to move CCTP from Ethereum Sepolia to AVAX Fuji. So let's first get Bob's address. So let's go to AVAX Fuji. Let's get his address. And then let's go back, switching networks to Ethereum Sepolia, and performing that function. So \CCTP, the first parameter we need was AVAX Fuji because we're moving from Ethereum to Sepolia, Ethereum Sepolia to AVAX Fuji, getting the address, and we want to move 1 USDC. So you can see that between each parameters are giving it a space. And once it's done, I'm just going to give it an enter, and now it's initiating the cross-chain transfer protocol, right? It's approving a USDC transfer. Once it has been done, right, I see that it has been initiated. I check whether or not it has been approved. Once it's been approved, we move on to the next step. So you can just wait it here. I'll put it side by side. Approval transaction be here. And now we're moving on. Now that has been approved, and that's the transaction ID. We're now initiating the USDC burn on the source chain. And once it's been burned, we do the next step again. You can see the output as such. Wait for the burn. Again, what used to take about 30 minutes now take as fast as 45 seconds. So it's a whole lot quicker. You can see the whole process being done. We've already burned, and now we're waiting for attestation. Okay, now we have read properties undefined, reading approved transaction. So there's a bug. Let's solve this bug. Let me try to solve it. I might have missed out a line of variables. So let me just because I have forgot to include a new function called wait for attestation, which is a loop that goes through and check whether attestation has been done, which is actually at the bottom. So I do need to include a new function here called wait for attestation. So let me just, for the sake of simplicity, let's get back here to circle service. Let's go back and let's replace this function. So in here, there's also a new function that I have yet to put in, which is wait for attestation. because it needs to be awaited before it can be done, right? So let's try once more. And in here, for the wait for attestation, you see that we're interacting with this current endpoint and passing the source domain and transaction hash. Previously, when I shared this function, attestation, I have yet to put in that function at the bottom, hence the error being thrown. So let's try and perform it once more, yeah? Let's go to network. If Sepolia, let's go and do this initiation of cross-chain transfer protocol. Again, let's give it some more time. But yes, so while it's working, yeah, this attestation service just runs in a loop until the status is complete. If not, through an error. And once it's complete, move on to the next step to enable the trigger of minting of USDC on the destination chain. So that is a very vital function for loop dev included into this function. So let's give it some time, let it approve. Once it's approved, now it's initiating the USDC burn. It's doing this function right now, interacting with the SDK create contract execution transaction to the contract address of token messenger on Ethereum Sepolia. And then it will output here once it has been done. You can view everything while it's happening here, right? And now it is waiting on the burn transaction, whether it's been completed. It has been completed. Now you're waiting for attestation service. Previously, it threw an error, right? Because it didn't have that the variable was not readable, but now it is readable. Attestation has been received. It's now checking whether it has now changed to like confirmed, right, for attestation. And once the status have changed successfully, confirmed, like you can see the cross-chain transfer initiation has been completed from Ethereum Sepolia to AVAX Fuji. Bob is now happy with one more USDC. Let's actually check Bob's address. Let's go to network, AVAX Fuji. Let's go and check his balance. So Bob is indeed like richer with one USDC. There's fees and such, hence, the estimation is around there. But initially Bob has $20, now has about 21 USDC. So in this process, you can see how quick CCTP V2 works in moving USDC across chains, in this case, Ethereum Sepolia to AVAX Fuji. So it's so easy, right? So you've learned how to build. I'm very excited. What's next? Remember at the start, I shared there's a free $100 credit. So go about and claim it. The link will be in the description. You can fork this template, or if you do not want to code this all out and want to see it working from the very start, go back to the replit.com to build on Circle. I have produced two templates. The second template that you can reference is cross-chain USDC bot with CCTP V2 and programmable wallets, which you can also fork it out, put in those variables at the start that you need to, and get started and experimenting with CCTP immediately. Last but not least, please join our developer community on Discord. We have awesome people, obviously, in our team that you can interact with, as well as the community. And hey, if you found this guide useful, I would appreciate it if you give it a like, share with your friends, drop a comment, share about what you're doing. Also, let us know what you'd like to see next, and see you in the next one. Thank you.